Okay, this is the sixth question on the packet, and I cannot lie, this is probably the worst one so far. I don't know, maybe I'm solving it not in the correct way, but at least like the way this I did this, it felt very confusing. But I don't know, maybe that's just me. We'll see. Um, Anyways, yeah, so I'm just gonna get into it. I'm also gonna be referencing my packet kind of as I look through this. I mean, I've done that for all of the videos so far, but this one I'm gonna be extra careful and make sure I get this right. Um, because this one's like actually a pain. Anyways, basically a projectile is fired straight up to height h, and the same projectile is then shot at a 45-degree angle, and it's asking what that new maximum height could be. So, that's kind of trash. That, that. So basically it's saying, right, like a projectile is shot up like that, and then it's also shot this way. And that is a 45-degree difference. And then this also would be 45 down here to kind of extend that and make it 90 on the dot. But I'm gonna just worry about this top section for now. And using this, I'm gonna just start with the straight up shot and figure out what the initial and final energy was, because I'm trying to solve for velocity right now. And the reason for that, right, is because this object is moving to the right and up, it's going to be experiencing both horizontal and vertical velocity. So if I can establish what at least vertical velocity is here, I can plug that in over here to get horizontal. And that'll help me find h as well. Let's also say like this would be big H going up. This new height is going to be big H. So for this guy over here, the very bottom, it's not going to be experiencing any gravitational. I mean, technically there would be the barrel of the gun, but I don't think they're going to consider that. So I'm just going to assume the point it's fired from is going to be, H is equal to 0 at the very bottom over here. Okay. So down here, there's going to be no gravitational. It's just going to be purely kinetic, which means our energy initial is going to be 1/2 mv squared. And then up here at the top, right, if it's at the top, like the maximum height is, I mean, it's about to fall down. And that means that it cannot move up anymore. It's changing direction. It was going up and now it's falling back down, which means there's a point at which it stops moving. And that is obviously the maximum point, which is what we're looking for. So that means our energy final will actually have no kinetic because there's no velocity. It's standing straight still. So it's just going to be mgh. Whoa, what the heck did I just click? Okay. And then these are going to be equal to each other. And the reason for that, right, is since this is going to come up again in like a second, but since it's like a perfect projectile motion scenario, there's no air resistance, there's no drag, which means there's no work being applied. The work is equal to 0, and that's actually equal to EF minus initial. We've explained this before. I don't want to overcomplicate things, but essentially, there is no work being applied on the bullet right now. There is no air resistance, there's no drag, which means that all of the energy up here is equal to all of the energy down there. So that means mgh is equal to 1/2 mv initial squared. And again, I'm going to solve for v initial here just so I can use that to get the velocity horizontally, or just to get the big H, right? So I'm going to cancel out both my m's. I'm going to move my 2 over to this side, and I'm going to also square root both sides. So I get 2gh square root is equal to v initial. This I'm going to hold on to. This will be important later. So going over to this side as well. First, I'm going to try and decompose my components here. What color do I want? Red. Okay, so this, I'm going to look for a vertical height first, which technically, uh, yeah, that's fine. So yeah, vertical height is going to be that, cosine, sorry, 45. That's going to be our vertical component. And this specifically, yeah, that is 1 over square root 2. Cosine 45 is equal to 1 over square root 2. And since we're multiplying it by v initial, you just multiply the two numerators, so you get v initial over square root 2 as our vertical component. Um, at the maximum height of this projectile, this is what I meant before by like the perfect projectile scenario. Since there's no drag, there's no horizontal components as this bullet fires, right? The only force affecting this bullet is going to be the vertical motion of the gravity pulling it down. So hypothetically, the bullet could continue traveling horizontally forever since there's nothing stopping it. But obviously, since there's gravity, it's going to fall down at some point, right? But what I'm trying to say is that at the top, the highest point, um, the vertical velocity would be zero, but the horizontal would not. The horizontal velocity would still be v initial sine 45, which would just be equal to this over square root 2. So this would be the horizontal velocity as we go this way. This is the velocity as we go that way. But obviously once this gets to the very top, it doesn't matter. It's going to become 0. So again, I'm going to do the initial firing and compare it to the final firing, which means at energy initial, I'm going to say 45 specifically, it's only going to be kinetic, right? So it's going to be 1/2 mv squared, mv theta squared. Sorry, I'm going to make sure this is, or sorry, mv initial squared. I'm going to, that'll look a little bit better. Cool. And then at the highest point, the velocity, we're going to be considering horizontal velocity, right? Because there's no vertical velocity, which means E final is going to be 1/2 m, and then this is going to be Vx squared, so our horizontal velocity specifically. And this is going to be equal to 1/2 m. And then this is where we plug in this cosine. We're going to bring that back over here, right? Because our Vx velocity specifically, or our V horizontal velocity specifically is this over 2, which is the same thing as this, right? So I'm really just taking from this, but it's the same thing as this. We're just taking those and sticking it into our actual equation. And again, since V is always squared anyways, it's going to end up being V squared over 2. That square is going to cancel out the square root over the 2, and it's only going to apply to our V. And then once you just kind of like shuffle those 2 around and stuff, you end up getting 1 over 4 mv initial squared. So this is our kinetic force at the top, but there's also still going to be gravitational force. Right? So the potential energy at this highest point, EF1, EF1, EF2, so this should be technically EF 45 1, EF 45 2. This is pretty, I don't know why I'm doing all that, but you don't need to. At this point, it's obviously going to be mg and big H. So we have big H over there. Okay, so now we have to compare everything. So I'm going to take this and I'm going to go 1/2 mv initial square, which is our initial. Or we do. Yeah, that's fine. Yeah, so I'm gonna do that is going to be set equal to our 1/4 mv theta squared plus our mgh. So this is kind of taking our big 2 values up here and our initial value, and all we did the same thing we did over here, right? Where we take our initial and we just move it to the other side because there's no work happening. So same thing here, because energy is being conserved, there's no work. Hello? How do I delete that? Okay, there. Yeah. So again, because there's no energy or there's no work, energy is being conserved, you just scoot E initial would have been like minus E initial over here, but we just kind of add it to the other side. So now that we have that, we just have to solve basically. So I'm going to change colors. Yeah. Yeah, I'm gonna cancel out my m's first, so I'm gonna get left with 1/2 v initial squared is equal to 1/4 v initial squared plus g h. And then can I scoot down a little bit? Okay. And then all we have to do is just shift this on over to this side, which is going to do it. Check. Yeah, yeah. So when you scoot this over, the other side, you're still gonna get 1/4. The initial 2 is equal to GH, right? And then okay, yeah. So we're trying to isolate H right here. So we're just gonna end up, what is it? Dividing by G, which leaves us with box this, divided by G. Take that over there. That gets you V initial squared over 4G, which is equal to H. Uh, like that. Um, so then this is where like it's like, whoa, really? Like, no way we have to do that. We have to substitute in this all the way over there. So because this is like squared, it's gonna cancel out the square root. So yep, this ends up being 2GH over 4G is equal to big H. Um, and then that's just gonna like you cancel out the H's. Um, and this is simply reduced to H over 2 is equal to big H. So the height of our final projectile is going to be equal to H over 2. And that means the answer would, can I scroll up? Would be C. Um, I don't know. This one is looking kind of crazy. I don't know how I feel about this question in general. Um, I am going to ask and see if this is the intended way of solving it. I don't know. I think this is kind of a ridiculous way to solve it. I hope this is not what's expected of us. Um, I was like honestly like beating my head against the wall and asking all of like the physics C kids that I knew, like, how the hell do you do this? But this might be it. I mean, I'll see. I'll probably ask. I'll put it in like the comments or like tell anyone who asks, like, yeah, like this is correct, this is not correct. But this is how I solved it. So essentially, when you're looking at this kind of question, you want to decompose it, right? So if it's asking you to find, it's giving you the initial height and it's asking you for the new maximum height, you're gonna use one height to like solve for the other. Uh, but I don't know. This one is honestly quite interesting, like in a bad way. But yeah.